Now, I want to do a quick review of continuity that we did today. So what I'm going to do is go ahead and show you an example, kind of work through it. So if we look over here, we have an example here where we have the function f of x. It's a piecewise function that's defined as three different things between different ranges. So when x is less than or equal to -1, we use the top function. When it's between -1 and 2, we use the middle. And when it's greater than or equal to 2, we use the bottom. So if we're thinking about continuous at x equals -1, the first order of business we always want to do is we want to try and figure out what is f of -1, what is the value at -1. In that case, that means we're going to use the top function. So what we're going to do is we're going to do 1 over -1 plus 4. So that's going to give us 1/3. So the value of the function at -1 is 1/3. The next thing we're going to do is we're actually going to look at the limit. And we want to figure out what is the limit as x approaches -1. -1, not 1. So it approaches -1 of f of x. And in this case, that means there's two separate problems. The first one we're going to do is the limit as x approaches -1 from the left. And the second is the limit as x approaches -1 from the right of f of x. And if we look at both of those functions, what we're going to find out is as it approaches it from the left, it's going to be that same one we used before. So it's going to be, we're going to go ahead and plug in -1 into that function. So we have 1 over -1 plus 4. So that's going to be 1/3 as it was before. Now what we want to do is we actually want to look at the second function, and that second function is going to be here. This is where x is greater than -1. So what we're going to do is we're going to plug in -1 for x, so 3 to the -1, which is also 1/3. Because those two numbers are the same, we know that the limit as it approaches -1 is 1/3. Because the limit, if the limit is the same, the answer to the limit is that number that they reach. And our third idea of continuity says function is continuous if f of -1, if the value at the function is the same as the value of the limit. So as x approaches -1 of f of x. So in this case, 1/3 equals 1/3. Therefore, what we can say is that f of x is continuous at x equals -1. So that's how we do it. We have to use all three of those steps each time. So again, if we wanted to go ahead and do the process for 2, step 1, we'd want to figure out f of 2. F of 2 is going to be the bottom function. So that's going to be 2 squared minus 1, which is 3. The next thing we're going to do is we're going to look at the limit as x approaches 2 of f of x. But again, the way that is going to be is we need to look at it from the left and the right. So we're going to look at as it approaches 2 from the left and as it approaches 2 from the right of f of x. So in the first case, as it approaches 2 from the left, it's going to be this top function, 3 to the x. So this guy is going to be 3 to the 2. 3 to the 2 is 9. This is the one we did before. 2 from the right is greater than or equal to 2. So it's going to be 2 squared minus 1. So that's 3. Now notice, these two numbers are not the same. So that tells me that the limit does not exist. And since these two can't be equal, we would say that f of x is not continuous at x equals 2. And the reason is because f of 2 doesn't equal the limit as x approaches 2 of f of x. So that's how we approach that one problem. That's our continuity. So that's one way to approach it. Another way that we're going to approach it is we could be given a problem where we need to find a value of x. So again, we're going to look at 4 because that's the kind of transition point. So we're going to look at f of 4. And f of 4 is going to be the first guy. So f of 4 is going to be 3 minus 4 squared. 3 minus 16 is -13. We're going to look at the limit as x approaches, not 3, 4, as x approaches 4. Approaches 4 of f of x, which again is going to be two problems. The limit as x approaches 4 from the left of f of x, the limit as x approaches 4 from the right of f of x. So from the left, it's going to be the one that we already did, this one up top here. This is from the left, so it's going to be negative 13. And from the right, we're going to plug in x plus k. So in this case, we're going to say that this guy is 4 plus k, because we're plugging in 4 for x. Now, for this to be continuous, these two people have to equal one another. These two things have to equal one another. That will make the limit exist. So what I'm going to do is I'm going to set negative 13, which is x from the left, equal to 4 plus k, which is x from the right. So again, this is the limit as x approaches 4 from the left. This is the limit as x approaches 4 from the right. We're going to solve for k. So subtract 4 from both sides. So negative 17 is going to equal k. So now if we were to actually make k equal negative 17, if k equals negative 17, then we can say that f of x is continuous at x equals 4, because f of 4 equals the limit as x approaches 4 of f of x, which in this case would be that negative 13. So there's our value of k that makes that a true statement. And that is how we would do continuity. So there's a few other questions on there if you want to practice them. I'm going to have this posted up on Schoology if you want to take a look at them, just to give you more opportunity to practice those. So I hope that helped. Please feel free to come and ask me questions if you have them. But this is where we are in terms of continuity.